Today we're going to solve the LeetCode problem 36, valid Sudoku. Determine if a 9x9 Sudoku board is valid. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each column must contain the digits 1 to 9 without repetition. Each of the 9 3x3 sub-boxes of the grid must contain the digits 1 to 9 without repetition. So note a Sudoku board partially filled could be valid, but it's not necessarily solvable. Only the filled cells need to be validated according to the mentioned rules. Okay, so the note here, it could be partially filled, and it could still be valid, but it's not necessarily solvable. So there's no really point to, I guess, solve this Sudoku and determine if there are digits 1 to 9 without repetition in each row, column, and grid. There's no point in attempting to solve it like that. My first thought would be actually to go through every row and check for each row, is there digits, are there no repeated digits between 1 to 9? And then go to each column, and check the same thing. There's no repeated digits between 1 to 9 in each column. And same with each grid. A grid is a little bit trickier because it contains rows and columns, 3x3. So this would be column 0, 1, 2, and this would be row 0, 1, 2 again. So my solution kind of suggests 3 iterations of this board, but we can actually do it in 1 iteration. So instead of like O of 3n squared, which is valid, it would still be O of n squared. We can do it in 1 iteration, just have it be O of 1n squared, and have it be O of n squared here. So what we can do is remember each number visited in each row, column, and grid. So we would have a dictionary where it'll be O of 1 lookup, constant time lookup, like rows, columns, and grids, where we record in each row, column, or grid numbered 1 to 9 if we have a duplicate value. So for example, in rows, we have at row number 0, so this very first one here, we have 5, 3, and 7. And if it just so happens there was another 7 here within row 0, then it will return false. Similarly for columns, in column number 0, we would have 5, 6, 8, 4, 7. So 5, 6, 8, yada yada yada. Okay. And we check for that entire row. For grids, it's a little bit trickier. It's not like we can store for 1 to 9 the values. So if we look at a grid here, so this would be a singular grid. This would be a second grid, and then a third grid. And this first grid is between the rows 0 to 3 and column 0 to 3. And the second grid here would be between rows 4 to 6, 4, 5, 6, and still column 0 to 3. So how can we keep track of these grids without having to, is in a simpler way? So what we can do is for each of these 3 groupings, 3, 3, 3, have them 0 indexed to a single value, like 0, 1, 2. And similarly for rows here, 0, 1, 2. So we know for for the this first grid here, we could say that the position is at 0, 0, where the 0 constitutes this range, and this, or this 0 constitutes this range, and this 0 constitutes the column range. And how do we calculate these? So we could simply do divide by 3. So, sorry, this would be 2, not 3. So 0 divided by 3 would be 0. 1 divided by 3 is 0. 2 divided by 3, it would still be 0. It would be, well, we would actually round. And then for row ranges 3, 4, and 5, 3 divided by 3, 1, 4 divided by 3, 1, and 5 divided by 3, still 1. So that's how we calculate these singular positions of the grid. So here grid, we would have like position 0, 0, and in this first grid here, we would have 5, 3, 6, 9, 8, 5, 3, 6, 9, 8. If we ever so found another value in this grid that's already in these grid coordinates, then return false. Now to code it up. So we have our rows dictionary. I think what I'm going to do is have a set instead, where the set will contain tuples of row number and the number found at this row number. Just comment that out. And same for calls. I'm going to have a set. The difference between a dictionary and a set is set only stores keys, dictionary stores keys and values. So this is going to be column number and the num, and grids. And how I'm going to store the grids in the set here is grid is a tuple, so it would be grid row number, grid column number, and the number. So if for say a row, if in row 0 we found the value 5, okay, great, we'll put it in here. If for that same row we find 5 again, so it'd be 0, 5, we already see it's in this set, so we return false. Okay, and then we iterate through for row in range 9 is going to hard code that 9 because Sudoku boards always 9 by 9. And for column in range 9, so if the board at that position should be row column is equal to a period, then we simply continue, don't do anything, just keep on iterating. Else, if at this column number we found this value already in our rows set, or we found the same board value in switch them. So we found in the row number we're looking at, we found this number value in rows, or in this column number we found this board value in columns, or when we divide by 3 to get the grid position, I store it as a tuple. Start the row. If we find that value in grids, then false. Else, what we're going to do is add these tuples to our sets. We're going to remember that we found this number at this row number. Let's copy paste it here. And if after everything we don't find any duplicates, return true. Okay, I'll try compiling first. Oh, I not defined. Oh, shoot. Just gotta copy paste that everywhere. Okay. Try again. Okay, now I'll try submitting. Okay, great. Thanks for watching.